Hello and welcome to part 2 of the chapter on recursion. I hope you have already watched the part 1 of this particular chapter. If not, you can always check out. I have given out the link in the description below. So this is the curriculum as per the CBSE website. So today's topic of discussion will be factorial, Fibonacci numbers, and one more algorithm I am going to discuss, which is the power of a number using recursion. Factorial and Fibonacci numbers will also be discussed using recursion only. So at first we need to know about a concept called recursive definition. So what is a recursive definition? A definition that is made in terms of smaller version of itself is called a recursive definition. If we can break a particular problem in terms of itself, then it is termed as a recursive definition. For example, if I write x to the power n, x to the power n means x will be multiplied n number of times. So if we actually multiply x n number of times, then it is a non-recursive definition. Okay, but we are not interested in the non-recursive definition. We need to write x to the power n in terms of itself, which can be written as follows. So we can write x to the power n as x into x to the power n minus 1. So here we have written x to the power n in terms of itself only. So this particular this is known as a recursive definition, and it will be applicable when n is greater than 1. But if n is equal to 1, then x to the power n is how much? X to the power n is x. For example, 2 to the power 1 is how much? 2 to the power 1 is 2 itself. And if n is equals to 0, then we get the answer as 1, since we know that the base of a number to the power 0 is always 1. Okay, so this is known as a recursive definition. So in case of this chapter, we will basically be dealing with only the recursive definition. So let's discuss about the power of a number in terms of programming, Python programming. So for the power function x to the power n, what we can do, see, from the previous part, you already know that for a sensible recursive code, we need two things. First is the base case, which will help the program to stop, and next is the recursive case, which will help the program to run until completion. So a recursive case would be x into, let's say we have taken the name of the function as power x comma n minus 1, and there will be two base cases. When n is equals to 1, the value will be x, and when n is equals to 0, the value will be 1, as discussed in the previous slide. Okay, I hope the recursive case and the base cases are clear. Now we will see this in terms of programming. Okay, so now what we'll do, we'll try to write a program to find the power of a number. So here this is the code for the power of a number. So at first, which line will run? From after the first line, the line number 6 will run. So what will come in the output screen? Enter the base. Let's say you have given the base as 2, so it is stored in the variable b. After that, what will come? Line number 7, enter the power bracket exponent. So let's say I'll give the value as 3. So p will have a value of how much? 3. After that, here we have done the function calling. Okay, so the name of the function is what? The name of the function is power. So we have sent b and p as the parameters to this particular function. So here, what will be the value of b that will be sent? 2. And what will be the value of p that will be sent? It is how much? It is 3. So now, so therefore b was 2, so now it will be copied to this particular variable a. So now a will be 2 and p is how much? P is 3. So 3 will be copied to the variable b. So now b will be how much? B will be 3 here. Okay, so after that, line number 2 will run. So if b equals to 0, is b equals to 0? No, b is 3. So this part will be ignored. So it will come to the else part. Else return a into power a comma b minus 1. So what does this mean? Return a into power a comma b minus 1 means, what is the value of a? The value of a is 2. into power, let's say I'll give it as p for short form. So a comma b minus 1, what is a is 2, b minus 1 is, what is b is 3, 3 minus 1 is how much, 2. So here again function calling will happen, that means this is the recursive case, so again it will go here. So now a is 2 and b is how much, b is also 2, because it has been reduced here. So after that it will again come to the second line, is b 0, no, b is not 0, it is 2, so it will again come to the fourth line, and since this case is true, so it will come to the fifth line again. So now what will come here, a into power a comma b minus 1. See, 2 was already there, so here it will continue from here. So what is a now, a is 2, 2 into power a comma b minus 1. So what is a is now 2, b minus 1, b is 2, 2 minus 1 is how much, 2 minus 1 is 1. So again this function is being called. So now the value of a is 2, what is the value of b, the value of b is now 1. Okay, so now again it will come to the second line, now the case is false now, so again fourth line. So here return a into power a comma b minus 1. So what is a is now 2, 2 into power a. What is a is 2 comma b minus 1, b is how much now, b is 1 now, 1 minus 1 is how much, 1 minus 1 is your 0. So 2 into p, 2 comma 0, p means the power function. Okay, I have just written it in a short form as just p. So after that again the function calling will happen. Now a is 2, b is how much, b is now 0. So here now this particular case will become true. So now from the second line it will come to the third line. If b equals to 0, is b 0? Yes, our b is 0. That means it will return 1. So this is called as the base case. So now this one will be returned to the part which has called it. Which part has called it? This part has called it. So now we'll get here the result as 1. So finally what we are getting? 2 into 2 into 2. So 2 into 2 into 2 is how much? 2 2s are 4, 4 2s are 8. Now the program will be terminated because now the function will be terminated. Why? Because we have got the final value of this return statement, and this 8 will be carried to which line? To this line. So now that 8 will be stored in the variable result. So I'll get the output as result is, what is the value stored in the variable result? 8. So I'll get the output as 8. So you will get the output something like this. Okay, if we are taking the value for base as 2 and the value for power as 3, then we'll get the result as 8. It will work for any base and any power. So let's run and see it. So this is our code. The function is power, the same code which I have explained just now. So let's run and see it. So if I run, let's say I'll give the base as 2, let's say the power as 3. So I'll get the answer as result is how much? Result is 8. I hope this is clear. Now let's go back to the slide. So here, so this was our code to calculate the power of a number. Here b equals to 0, it is helping the program to stop, so it will be known as the base case. And this particular line, the else part, it is known as the recursive case, because it is helping the program in running again and again until you have got the result. After that we have got the output as follows. So this 2 and 3 can be replaced by any number. Okay, here just I have taken the example of 2 and 3 so that I can explain it to you quickly. Let's go to the next algorithm, which is the factorial of a number. All of you know about factorial. So what is factorial? The factorial of a non-negative number is defined as the product of all the values from 1 to the number. That means if you have factorial, let's say you have factorial 5. Let's say you have factorial 5. Factorial 5 means what? 5 into 4 into 3 into 2 into 1. That means 5 4s are 20, 3 2s are 6, 20 into 6 is how much? 120. Okay. So this is the factorial. So factorial n will be 1 into 2 into 3 into ... up to n, but this is a non-recursive definition. Why? Because we are just multiplying the terms, but here we are not interested in the non-recursive definition. We are interested in the recursive version of the same. So what are the recursive version? For making it a recursive version, you should be very clear about the base cases and the recursive cases. So what will be the base cases here and what will be the recursive cases here? Here the base case will be factorial n equals to 1 if n is less than 2, and if for any value of n greater than equal to 2, will get the result as n into n minus 1 factorial. Okay, because you see, so this is our non-recursive definition. But if I want to write it in a recursive fashion, then factorial 5 can be written as 4 into factorial 5 can be written as 5 into factorial 4. Okay, then we can again break up factorial 4 into factorial 3. So this is called as the recursive definition. And the base case can be, and base case I have already discussed, if n is less than 2, then factorial n will be equals to 1. So this particular line will help the program to stop, and this will help in finding out the values repeatedly until we get the final answer. Okay, so we'll see the code for that. Okay, so this is the code for finding the factorial of a number using recursion. So at first line number 2 will run, then from line number 2 it will come to line number 7. So what will be displayed? Enter a number to find its factorial. Let's say you have given the value of n as 5. So n will take the value as how much? N will take the value as 5. After that, what is written here? What will come? The factorial of n is, so in the output screen it will come like this, the factorial of n. What is n? N is 5, so it will come factorial of 5 is, here the function calling is happening. What is the function calling here? Fact n. So what is our value of n? Our value of n is 5, so 5 will be carried from here to here. Okay, now n will have the value of how much? N will have the value of 5. After that, if n less than 2, okay, if n less than 2, is our n less than 2? 5 is less than 2. Is it true or false? It is false. Since it is false, it will come to which part? It will come to the else part. Okay, so in the else part, now what is there? Return n into fact n minus 1. What is n? N is your 5. 5 into fact n minus 1 means 5 minus 1. 5 minus 1 is how much? 4. So here again we are calling the function fact with the value as 4. So now this time the value of n will be how much? 4. Now is 4 less than 2? No, 4 is not less than 2. So again this part will be ignored and the control will come to the which line? 5th line, and after that the 6th line will be executed. So in the 6th line what we have? Return n into fact n minus 1. What is n? 4. 4 into fact n minus 1. N minus 1 means 4 minus 1 is how much? 4 minus 1 is 3. So again the function calling will happen. So it will go to the second line. If is now the value of n is 3. Is 3 less than 2? No, 3 is not less than 2. So again it will come to the 5th line, and then following it will come to the 6th line, and then again n into fact n minus 1. What is n? N is 3. 3 into fact n minus 1. N minus 1 is how much? It is now 2. Again function calling will happen. Is 2 less than 2? No, it is 2 is not less than 2. So what will happen? Again it will come to the 5th and it will be followed by the 6th line, and here again what? Return n into fact n minus 1. What is the value of n now? The value of n now is how much? 2. So 2 into fact n minus 1. 2 minus 1 is how much? 1. So here again function calling will happen. So here what is written? If n less than 2. What is now value of n now? 1. Is 1 less than 2? Yes, 1 is less than 2. So what will be returned? 1 will be returned. 1 will be returned to where? 1 will be returned to this particular part. So what we'll have, 2 into here 1, so we'll get the final value. Now how the other values are carried? Okay, 5 into 4 into 3 into 2 into 1, how much it is? 5 2 is 6, 5 4 is 20, 20 into 6 is how much? It is 120. So as we have got the final value as 120, so it will be returned to that particular line which has called it. Which line has called it? The 8th line has called it. So this particular value 120 will be returned here. So we'll get the answer as the factorial of 5 is how much? The factorial of 5 is 120. So if we run this particular program, you'll get the output something like this. Enter a number to find this factorial. If we give the input as 5, we'll get the output as 120. Now let's run and see this particular program. So this is the program to find the factorial of a number using recursion. So if we run it, let's say I'll give the input as 5 only, so we'll get the output as 120. How 120 has come, I have already explained it. Now let's go back to the slides. So this was our code for finding out the factorial of a number. Here n less than 2, this particular case can be termed as the base case because it is helping the program to stop. So it is the base case, and this line is helping the program to run again and again until completion. So it is a recursive case. So since it has both base cases and recursive case, it can be called as a sensible recursive code. So if I run it, we'll get the output as follows for inputs, for input as 5. Okay, now let's go to our last algorithm, which is Fibonacci numbers. Okay, I think we have already done Fibonacci numbers in class 11. So but now we will do Fibonacci numbers using recursion. So what is Fibonacci number? It is a series of numbers in which each number is the sum of the two preceding numbers. Okay, so here what is the Fibonacci series? Here this is the Fibonacci series. Okay, so let's try to make you understand the concept of Fibonacci series. Here, so the series will start from 0. The first number is 0, the second number is 1. How will the third number be formed? Third number will be formed by the addition of these two numbers. 0 plus 1 is how much? 1. Next number will be formed by the addition of this and this number, that is 2. Next number will be formed by the addition of these two number, that is 3. Next number will be 2 plus 3 is 5. Next number will be 3 plus 5 is 8, and so on. So this series is known as the Fibonacci series. Okay, now let's, so this is the series. So 0 is the first term, 1 is the second term, 1 is the third term, 2 is the fourth term, 3 is the fifth term, and so on. Next, we'll try to write a program for Fibonacci series using the concept of recursion. So let's see it. Okay, so this is the program code for Fibonacci series. So at first line number 1 will be executed. After that line number 8. So what will be asked? Enter the number of terms till which you want to display the Fibonacci. So let's say we'll give the input as 5. Okay, so now what is the value of n? The value of n is 5. So after that what we have? For I in range 1 comma n minus 1. So what will be the range for I in range 1 comma what is n? N is 5. 5 plus 1 is 6. So the accepted values will be 1, 2, 3, 4 and 5. You know the meaning of range function. It will take from the first value to the last value minus 1. So these are the possible values in the range. So after that, now what will be the value of I? The value of I will be 1. It will take 1 and it will come inside the for loop, and then what will happen here? Print Fibo I. So this is the function. So now function calling will happen. What will be the value of I now? The value of I now is 1. So 1 will be taken to this particular line. So now the value of 1 will be how? N will be how much? The value of n will be 1. Let's say this is our output screen. So here if n equals to 1, is n 1? Yes, n is 1, so it will return how much? 0. So 0 will be returned to the 10th line. So here we are using the print function, so what will come as the output? 0. After that what we have? Comma. 0, then comma will come here. Okay, after that what will happen this time? Then again it will take the value of I as 2. So now Fibo I, what will be the value of I now? The value of I now is 2. So the value of n will be how much? The value of n will also be 2. So now if n equals to 1, is n 1? No, n is not 1. So it will come to the 4th line. If n equals to 2, is n 2? Yes, n is equals to 2. So what will be returned? Return 1. 1 will be returned to which line? This 1 will be returned to the 10th line. So here since print function is used, so we'll directly get 1 as the output now for the second iteration, and then we have what? We have comma here. Okay, so after that what will happen? We erase certain things. So after that, this time the value of n I will be taken as 3. So what will happen now? Fibo I, what is the value of I? I is 3, therefore n will be 3. If n equals to 1, no, n is not 1. If n equals to 2, is n 2? N is not 2. So it will come to which part? It will come to the 6th line, which is the else part. In the else part, what we have? We have the actual recursive part, which is return Fibo n minus 1. So which is return Fibo n minus 1. What is n? N is your 3. So 3 minus 1 is how much? 2 plus Fibo n minus 2. N is 3. 3 minus 2 is how much? 3 minus 2 is 1. So now again this particular function will be called. So now with the value of n as how much? 2. So it will come to this particular line. If n equals to 1, n is not 1. If n equals to 2, is n 2? Yes, n is 2. So the result of this part will be how much? The result of this part will be 1. So because 1 is being returned from this part, after that what we have? Plus f1. So again it will be called, this time with the value of n as 1. If n equals to 1, what will be returned? 0 will be returned. So ultimately the result of this will be 0. So finally what we'll get? We'll get 1 plus 0. 1 plus 0 is how much? 1 plus 0 is 1. So since we have got the final result as 1, this 1 will be carried to the 10th line. So in the 10th line, we'll get the answer as how much? We'll get the answer as 1. 1 is the final answer. Then again we have what? Again we have a comma here. Okay, I hope the iteration up to number 3 is correct. Let me erase the board a little bit. Okay, so after that, now what will happen? Now the value of I will be taken as 4. So Fibo 4. So here n, the value of n will be how much? The value of n will be 4. We have given the actual value of n as 5. So these are the ranges. So if n equals to 1, n is not 1, n is not 2. So it will come to the else part. So else Fibo n minus 1. N minus 1, 4 minus 1 is 3 plus Fibo n minus 2. 4 minus 2 is how much? 2. So Fibo 3. So Fibo 3 will, so the function will again be called, this particular function. So if n equals to 1, n is not 1, n is 3 now. If if n equals to 2, n is not 2, so it will come to the which part? Else part. Fibo n minus 1. 3 minus 1 is how much? 2. Fibo 2 plus Fibo how much? N minus 2. 3 minus 2 is how much? 3 minus 2 is 1. So for Fibo 2, again it will go here. So this particular part will become true. So we'll get how much? 1 plus Fibo 1. What is the result of Fibo 1? Fibo 1 result is 0. So ultimately F3 is how much? F3 is 1. Okay. Plus F2. F2 means Fibo 2. What will be the result of Fibo 2? It will go here. We'll get how much? Result of Fibo 2 is 1. So ultimately we are getting 1 plus 1, the final result as 2. So this particular 2 will be returned to the 10th line. Okay, so as print function is used, so we'll get here as how much? 2. After that end is there, so here comma will come, and now the final value of the range is will be executed, which is how much? The final value of the range now is 5. So the value of n which we have taken was 5, and now the final value of the range will also be 5. So here what will be carried in place of I? 5 will be carried in place of I. So 5 will be carried from here to here. So what will be the value of n now? The value of n is 5. So if n equals to 1, n is not 1. If n equals to 2, n is not 2, so it will come to the else part. So here what we'll have? Fibo n minus 1, that means Fibo 4 plus Fibo n minus 2. 5 minus 2 is how much? 3. So here in the previous part we have already got the so okay, so I'll run it again and show it to you, otherwise you may be confused. So Fibo 4, so this time again now the value of n will be taken as 4, and it will come here. Is n 1? No. Is n 2? No. So it will come to the else part. Fibo n minus 1, so from this part Fibo 4 minus 1 is 3 plus Fibo n minus 2. 4 minus 2 is how much? 2. So then again there will be a branching from here. Fibo 3. Fibo 3 means how much? It is not 1, it is not 2, so it will again come here. Fibo 2 plus Fibo 3 minus 2 is how much? 3 minus 2 is 1. So Fibo 2 is how much? Fibo 2 is 1 plus Fibo 1 is how much? Fibo 1 is 0. So for 3 we are getting the value as 1. For 2, see, we'll get the value as 1. So ultimately Fibo 4 we are getting how much? Fibo 4 we are getting as 2. I have already shown it here again, and in the previous step also I have shown that the value of Fibo 4 is how much? The value of Fibo 4 is 2. So here we are getting 2 plus. What is the value of Fibo 3? The value of Fibo 3 is, if you can consider only this part, only this particular part, you will get that the value of Fibo 3 is how much? 1 plus 0 is 1. So this one will be returned here. So we'll get 2 plus 1, the final value as 3. So we are getting the final result here as 3. This tree will be returned to which line? This tree will be returned to the 10th line. So here what we'll get? The output as 3, the last number of the series as 3. After that comma will be there. So now you can see that the entire list of values within the range has been used up. Since it is used up, now it will not go inside the loop again. It will come to which line? It will come to the 11th line. What is there in the 11th line? Just a print function with 3 dots. So after comma what will come? 3 dots will come. 3 dots indicates that it is an infinite series. That means it will never stop. You should write it in your copy and just try to trace it by yourself. Then the entire concept of Fibonacci series will be clear. Okay, so the output will get as this. Okay, I'll just run and show you the output. So this is the program for Fibonacci series. So if I just run it, if I give, let's say I'll give the input as 7. So if I give the input as 7, you will get 7 terms, which are 0, 1, 1, 2, 3, 5, 8. Here the next number is formed by the summation of the previous 2 terms. I hope this is clear. Let's go back to the slides. Okay, so this is our code for Fibonacci series using the concept of recursion. Here n equals to 1 and n equals to 2. These are our what? These are our base cases. Here we have 2 base cases, and this particular line, the else part, it is the recursive case. Then finally we'll get the output as this. For the input as 6. You can take any input, but the concept will be the same. The concept in which it runs is the same. So in this particular part of the chapter recursion, we have discussed about power of a number, factorial, and Fibonacci numbers. In the next part, we'll be discussing about recursion on arrays and I'll be explaining recursion on arrays with the help of an algorithm called binary search. I hope that this session was useful. Thank you very much.